So we had practice, guys, using our power rule. Now let's take a look at our next rule we're going to take a look at, which is we know the derivative of natural log of x is 1 over x. So what happens when we want to find the antiderivative of 1 over x? That's going to be the natural log of the absolute value of x plus c. So we're going to practice using this rule in the next couple problems. So if you take a look on page 10, letter C, we've got our integral of 2 minus 3y squared quantity divided by y. So first thing I'm going to do is I'm going to break this larger fraction up into two smaller fractions. So I have my integral of 2 over y minus 3y squared over y dy. Again, I'm going to pull this arbitrary constant of 2 out, so I have 2 times my integral of 1 over y dy minus 3, pull my 3 out of my integral, y squared divided by y is a y. Be careful, guys, when you're splitting up your integrals and you have constants. Remember, 2 is being divided by y here. So the 2 is only going to go for this first integral here. The 3 is only going to be applied to this integral right here before you actually do your integration. So now I can actually find the antiderivative. So I have 2, again, 1 over y, the antiderivative of 1 over y is the natural log of the absolute value of y, minus, we just did our power rule a few minutes ago, 3 times y squared over y, or excuse me, y squared over 2, plus your constant. So there's the antiderivative for letter C. For D, so we know the derivative of e to the x is just e to the x. So again, your integral rule for e to the x. Again, we're going to love e to the x because guess what? Your integral of e to the x is just e to the x. So if you take a look at letter D, so again, I can rewrite this particular integrand as quantity. Again, I can pull out that constant of 1 over 3. So I have 1 over x dx minus, pull out that 2, times your integral of e to the x dx. Now I can go ahead and find my antiderivative. So again, my antiderivative, again, take 1/3. The integral of 1 over x is just going to be the natural log of the absolute value of x minus 2 times the antiderivative of e to the x, which is just e to the x plus c. Here's our trig. So again, all of our trig derivative rules are over here on the front. So again, we know what the derivative of negative cosine x is, that's sine. So my integral of sine x is going to be negative cosine x. So again, you've got to know all these rules for the antiderivatives as well. And again, there's another one up there. So when I look at the integral of cosine t minus the cosecant t minus cotangent t, again, I can take the integral of cosine of t dt minus your integral of cosecant of t, cotangent of t, dt. So the integral of cosine t, well, whose function has a derivative of cosine? That's just going to be a sine of t. Minus, now which trig function has a derivative of cosecant cotangent? That's going to be a cosecant of t plus your arbitrary constant.